This is assembled Tamiya Tracked vehicle and it can go only forward or reverse. But then I added double gear motor, a scaffold, Arduino Uno R3 and started to add sensors to it. Now it became alive. It follows the light and it can follow your flashlight or it can search for the brightest light in the room. But not everything as easy as it look like. Let me tell you more about the structure of this robot and then I will tell you what kind of challenges could be and what kind of funny tricks you can make with it. This is close-up of the robot and you can see here is the ping sensor, ultrasonic sensor. This is the double gears from Tamiya. This is Arduino Uno R3 from SainSmart breadboard. On the breadboard you can see the photoresistor 1, photoresistor 2, then underneath of the robot, underneath you will see the battery pack. It contains 8 AA batteries, and underneath all this structure this is the motor shield, also from, I believe, from SainSmart. It's very simple motor shield containing one big bridge, H-bridge, but it is more than enough to drive this vehicle. This vehicle drives pretty easy and pretty fast and with pretty good torque. I didn't fix the battery pack, so it falls out if the tank tries to climb something. So all wiring was done just by like breadboard, just by connections without any soldering, except the motors. You have to solder wires to motors, otherwise you cannot connect to them. Also, I need to say that one of the motors failed, but fortunately I had another motor from the Tamiya Tracked vehicle, which I replaced. So this is it. All the rack, all like the scaffold is improvised and just done from whatever I had, like plastic bottle that I had at home. And this is it. From this side you can better see the motor shield that I use, and this is the button on the motor shield which powers up, gives the power to the motor shield, but also I use the motor shield to take 5 volts and energize the Arduino board. So actually this power pack serves for the power for the motors and for the brains themselves. Some people prefer to provide the source of power for the brains separately, but in order to save space and weight, I use this power pack for both purposes. Maybe it's wrong, I do not know. Each photoresistor is connected to analog input. Sorry for the quality. I use just the phone to video this, to tape this. And also I use 1 kilo ohm resistor for each photoresistor. in order to get rid of the background and the noise, and they serve very well. I tried also 100 kilo ohm and they also worked fine, but in general they give much higher reading on the analog pins. So this is it. Signal for electrical motors is coming from pins that allow to use analog output. So even the power pack that I have for my robot gives 12 volts. I can I can send to the motors 2.5 or 3 volts only using these pins. Ultrasonic sense is very simple. It's the cheapest from Amazon. It has 4 pins, one for power, one for ground, and one to trigger the signal, ultrasonic signal, and one to receive the echo. I connected these both pins on the same line on the breadboard and use only one pin in the brain, and the way it works that when it sends the signal, I determine it as an output. After it sends the signal, I reprogram it to be an input and receive the echo. So one pin on the brain on the Arduino can serve for these 2 pins on the ping sensor. It's very simple and it works perfectly well. Accidentally, I videotaped how one of the motors failed, and you can see on one side the robot turns just perfectly well, and other side it stops because it is supposed to turn on the motor of the side opposite to the light, so to turn to the light, but it stops because the motor doesn't work. So I spent some time. I thought something was wrong with the sensor, but actually the motor was bad. Now the motor is fixed and the robot behaves that is supposed to do, and you can see how it jerks left right all the time. The reason for that is the code is very simple. If the light is bright on the left, turn right engine. If the light bright on the right, turn left engine. So it readjusts to the light every fraction of a second instead of moving forward smoothly. So next step, I will fix that thing. By the way, you can see that the tracked vehicle drives across the rough terrain. It's pretty easy for that, and it is pretty good. Now this problem is fixed, and you can see that robot moves much more. Its movement is much more smooth and much more efficient, so it drives faster. It doesn't search for light, jerking left and right, so it just goes toward the light without readjusting every 1 degree. And how it was how I made it, it's actually very simple. In the code there is a requirement that if the difference between left and right sense is not more than 10%, just move forward instead of moving toward the brightest side. And only if something is brighter than more than 10% difference, then it will turn to that side. So in order to make it jerk a little bit again, you need to move your flashlight back and forth, or when the robot is struggling between the bright flashlight and bright day sunlight. Otherwise, and even in this case, when it searches for the light, it's much more efficient. It's not like switching the motors back and forth every fraction of a second. It moves much more smoother. If you have questions, please write me.